Today we are learning about symmetry. Please copy down the standard benchmark indicator on a clean page in your math notebook. The student will identify and describe a line of symmetry. Symmetry. A figure has reflection symmetry if it can be reflected on itself. The line of reflection is called the line of symmetry. Some figures have more than one line of symmetry. So if we look at our isosceles triangle there, it has one line of symmetry from the top straight down to the bottom. And if you folded it over that line, both halves would line up perfectly. The second one, the cross, or the plus sign, however you want to look at it, has four lines of symmetry. Each one of those lines, if you folded the shape over it, it would land exactly on top of itself. And then the third shape has two lines of symmetry. You can either do it horizontal or vertical. And both times, if you fold it, it will end up exactly on top of itself. A figure has rotational symmetry when it rotates onto itself in less than one full turn. So the plus sign there is a 90-degree or quarter turn rotational symmetry. So every 90 degrees I turn it, it will land exactly on top of itself. The Y has 120-degree or 1/3 turn rotational symmetry. So every time I turn it a third of the way around, it will end up exactly on top of itself. Finally, the last shape has 180-degree or half-turn symmetry. So if I turn it 180 degrees, it will land on top of itself. For the triad, we need to tell if each figure has reflection symmetry, rotational symmetry, or both. If it has reflection symmetry, how many lines of symmetry are there? If it has rotational symmetry, what is the smallest turn that will rotate the figure onto itself? Number one is an isosceles triangle. So it has reflection symmetry, and it has one line from the top point straight down to the middle of the bottom. So we're going to draw that in. For number two, we have both reflection symmetry and rotational symmetry. So for the reflection symmetry, it has four lines of reflection symmetry. For rotational symmetry, it takes a quarter turn or 90 degrees. Figure 3 only has rotational symmetry, and it takes a half turn to get it to land exactly on top of itself. Finally, for number 4, it has both rotational symmetry and reflection symmetry. For reflection, it has 3 lines going from the top of each of the loops straight through the middle of the shape. And for rotational symmetry, it's a 1/3 turn or 120 degrees. Please copy down all of the work and make sure this page is glued in your math notebook.